stomach is the pink, tiny little pink blob. And you'll see on the left, the rumen is the stomach of the cow. You can see that the horse has only one chamber, which means they're monogastric. The cow has multiple chambers. The horse stomach holds only 2 to 4 gallons at a time. The cow stomach holds 25 gallons. So why I'm explaining this is because the emphasis on the digestion in the cow is centered very primarily in the stomach, whereas the horse, that is not the main source of digestion in the horse. So as we go down, we can see the small intestine in white. It's kind of similar. The horse has a quite a bit longer one. And then that empties out into the cecum, which is a strange little structure. You can see it just at the top, that purple section. You can see the cow has one that holds about 2 gallons of food material at a time. The horse holds 10 gallons at a time. So this is the first section of the hindgut in the horse, and you can see it's quite exaggerated already. Then we get into the hindgut or the colon, and you can see very clearly that the large intestine in the cow is much smaller surface space compared to the horse. So large intestine in a cow holds about 2 gallons at a time, whereas the hindgut of the horse, it's about 40 gallons at a time. So that's a huge difference in and a different focus. So the cow's stomach is the main fermentation chamber. The horse's the horse's hindgut is their main fermentation chamber. So why do these two different animals actually even exist? That was my question. And why are horses so specialized? Because this system, the horse's hindgut, is very advanced and extremely specialized in why it does what it does and why it looks the way that it does. So we talked a little bit about evolution already. 200 million years of adapting to the environment. That's a pretty long time. There was a major climate shift in the evolutionary time frame of horses, where they went from tropical, very steady tropical, same kind of temperature all year round, to seasonal cycles, so big swings in temperature, and that actually changed the whole entire landscape, the environment, and the forage that these animals had access to. So when plants go into their fall and winter seasons, you'll notice that in the fall there's a lot of seed heads on the grasses. A lot of plants are in that seeding stage, and when they get to that mature stage, the cellulose fiber in those plants gets higher and higher and higher until the plant goes into hibernation mode. So the fiber, their dietary fiber in their environment changed quite drastically when it shifted from tropical to seasonal. So they had to adapt to that big change. Fiber is quite hard to digest, so the only really healthy way to do that and get anything out of it and have it be beneficial is to ferment it, which is kind of our large intestine does that in a lesser capacity. Horses have this very powerful fermentation system that can break down very, very advanced, very thick fibers, plant fibers. So that was kind of the key point for me in the research that I was looking at, is this huge swing from very soft plants that didn't really mature, not as much fiber, very easy plants to digest, and then they went into this fiber overload. So this actually is the reason why horses started to increase in body size, because you would think that increasing in body size is not an efficient way to go, because the larger you are, the more energy you expend. So the scientists in the research that I was looking at were questioning, why would horses get larger? And the hypothesis is that it was to make room for this giant fermentation system, because it didn't have enough space, enough surface area to be at full capacity without increasing the horse's body size. So that was all very fascinating to me. I hope it was interesting for you. We're seeing in horses, if we kind of fast forward to now, is a lot of really gut-focused diseases. So much dysfunction in the digestive system. So gastric ulcers, it's estimated between 70 and 80% of domestic horses have some level of ulceration in their stomach, which is kind of shocking. If that was a human statistic, we would be pretty concerned, I think. Hindgut ulcers are not well studied, but they do exist. And I think that if more horses were being scoped from the hind end, we would be seeing some dysfunction in that area as well. Colic is the most common cause of early euthanasia in horses, and that's also a pretty heartbreaking thing to imagine. Probably if you've been working around horses long enough, you've probably seen this happen. It is not fun for the horse, it's not fun for the owner, and it can result in death. Free fecal water syndrome is something that's becoming more common, and we'll talk about some of the reasons why that might be. And then another problem that horses are having that's not as much on the radar in conventional medical terms is hindgut acidosis, which I'm going to talk about a little more later, and insulin resistance, which is a metabolic dysregulation in the body, which is related to how the horse is metabolizing its diet and everything else that it's consuming from the environment. I took some studies that have been done on feral horses where they have taken their manure and tested it, DNA sequenced it to identify the specific species of plants that these horses are eating throughout the year. So the major one that I used was from Rangeland and Ecology Management, and that was done in 2019, and they followed those horses for an entire year, so all 4 seasons, to see what they were eating. So in the study, it actually goes through what they were eating in each season, which is really cool. We don't have time to totally go into that, but I wanted to show you this. So we have grasses is the primary way that horses get their nutrition, and in the wild horses, these guys were eating 16 different species of grasses. So that is a major difference in what we are feeding now, just that alone. You'll note that also it's about 70% of their total diet, which is not their whole diet, right? So what else do they eat? Shrubs, trees, and bark was at about 12%. They did eat primarily about 7 different types of trees, and those are very important part of their diet. So they don't often have access to that unless they're turned out. But I have observed often that when my horses are turned out, that they do access these plants and they use them.